Viruses. Especially now, we fear them more than ever. But do you know that we could actually use them as our ally against bacteria? Okay, first of all, what exactly is a virus? Viruses are obligate intracellular parasites, meaning that they need to infect a host in order to reproduce. Let's take a look at a certain type of virus, a bacteriophage, also known as a phage. A phage is a certain type of virus that attacks and kills bacteria. And this is what makes phages so useful in treating bacterial infections, as an alternative method to antibiotics. Unlike antibiotics, which are designed to kill all bacteria, phages have the advantage of being host-specific. Now, what does this mean? Most phages work like a lock and a key. Imagine you're trying to get into your house. Using your key, the lock opens. But for any other lock with a different keyhole, your key won't work. Similarly, a phage can only infect certain species of bacteria whose receptors recognize and bind to the proteins on the phage's surface. Since different species of bacteria have differently shaped receptors, the phage can only infect the particular bacteria whose receptors match. These bacteria are called the phage's host range. Now, with phage therapy, we can use phages to only target bacteria causing infection and leave the other healthy bacteria alone. This leads to the next idea of resistance. With antibiotics, all bacteria are targeted. The bacteria that survive the antibiotics will become resistant to future antibiotic treatments. But since phages only infect the bacteria within their host range, less bacteria are exposed, and therefore less bacteria will become resistant, making phage therapy a much better alternative. Next, phages have the ability to self-amplify, which means they can produce more of themselves in a shorter period of time. While antibiotics are usually administered over multiple doses, phages can be administered just once. So, how does phage therapy work? The phage injects its genetic material into the bacteria cell and hijacks the bacteria control system to start mass-producing more phages. The bacteria will eventually lyse or burst, releasing all the new phages that can go on to infect even more bacteria. This cycle, known as the lytic cycle, creates a positive feedback loop where a small dose of phages can grow exponentially and kill the bacteria population much more efficiently. So, despite our fears about viruses, they can be immensely useful, but it's still a work in progress. But by exploring it, we're reinventing our relationship with viruses to turn them from our enemies to our allies.